All right, here's how you do problem number one of lesson 3.01c. We are dividing monomials. Remember that a monomial, it means one term. It's when you only have a number like 7 or only like a letter like x, or when you multiply numbers and letters and you see them together like negative 2y and ab. Today, what we're going to do is we're going to divide monomials. And basically what you do is you divide the numbers with the numbers and you divide the letters with the letters. Okay? So for example, in problem number one, which I'm going to do something similar, not going to do the same one, we have x to the, let's say I give you x to the 20th power divided by x to the 7th power. And I hope you notice that on the top, we have a monomial, and on the bottom, we have another monomial. How you divide letters that are the same? What you're going to do is you're going to keep the letter, okay? And what you're going to do now is subtract the exponent. Subtract the exponent of the top minus the exponent of the bottom. Always top minus the bottom, okay? And we're going to get x to the 13. Look how quickly I did that. All right, let's go to the next one, problem number two. In problem number two, we have, again, we dividing monomials. And the way you divide monomials is you divide the numbers with the numbers. The numbers, we call them coefficients, and the letters with the letters. So in problem number two, I'm going to do something again similar. Let's say we have 7x to the 15th power divided by negative 7x to the 11th power. And on the top, I have a monomial of the fraction bar. And on the bottom, I have another monomial. How you divide? You're going to divide the numbers with the numbers. So let's find out what is 7 divided by negative 7. You can use a calculator. That will be negative 1. And now you're going to divide the letters with the letters. Okay, let me change the color. I didn't want to use that color. Let's say I use the orange one. So the letters with the letters. And how do we divide the letters? Every time you divide letters that are the same, you keep the letter and you subtract the exponent. So 15 take away 11, that will be 4. Now get used to that in algebra, when a letter is being multiplied by 1, okay, or negative 1, we do not write the 1. Or in this case, I'm going to keep the negative, but I'm not going to write the 1. So the final answer could be negative x to the 4th power, okay? It has to do that any number multiplied by 1 is itself. That's one of the properties of numbers that you have learned previously. Let's go to the next problem. In problem number 3, again, we're dividing two monomials. So in this case, we have multiple letters. Again, I'm doing similar ones. So let's say I have x to the 24th power, y to the 18th power. That's a monomial. And I'm going to divide by the monomial x to the 21st power, y to the 17th power. Okay? And that's another monomial. How you divide this? Well, when you're dividing monomials, you divide the numbers by the numbers, but I don't have any big number in front of the letters. So I'm not going to be dividing numbers. However, I do have letters. And when you divide letters, you divide the letters that are the same. So I'm going to divide the x's with the x's. So I'm going to keep the x in this case. And again, what I'm going to do with the two exponents, I'm going to subtract them. So 24 take away 21, that will be 3. Okay. Now I'm going to the next letter, in this case, the letter y. So I'm going to divide the y's. So when you divide y's, you keep the y. And again, what you're going to do with the exponents, you're going to subtract them. So you get 1. Also start getting used to when the exponent is 1. In algebra, we do not write it. So the final answer here is going to be x to the 3rd power, y. Okay, there's an invisible 1 there. In algebra, we do not write the exponent 1. Okay, let's go to the next problem. All right, in the next problem, we have question number 4. We divided monomials by monomials. So let me put this one. Let's say I give you something like negative 4x to the 15th power, y to the 20, let me see, I'm going to say 22nd power. That's a monomial divided by 6x to the, let's say I give you the 22nd power, y to the 27th power. Okay, so how do we divide monomials? We're going to divide the numbers with the numbers. I'm going to divide negative 4. I'm going to divide it by negative 6. So using your calculator, when you start dividing negative 4 divided by 6, I'm going to do it. Negative 4 divided by 6. You're going to see you're going to get a long decimals. When you get those long decimals, don't type the decimal. Okay, what you're going to do is you're going to write your answer as a fraction. So click on this circle here and look what will be my answer as a fraction. So it's going to be, when I divide the fractions, I'm going to get negative 2/3. Okay, now I'm going to divide the x's. So let me change color here. So dividing the x's, when I divide the x's, I'm going to keep the x, I'm going to keep it, and I'm going to subtract the exponents. And again, leave the calculator because most likely here you're going to need it. So you're going to take 15, the top exponent, subtract the bottom exponent. Okay, and you can see I got negative 7. Now I'm going to divide the y's. Let's go with the last one. Okay, so let me change the color of my pencil. Now we're going to divide the y's, and when I divide the y's, I keep the y, and again I'm going to subtract the exponent. So the top exponent, 22, subtract 27, and you can see I got negative 5. Now a lot of times you can leave your answer like I got there, negative 2/3 x to the negative 7th power, y to the negative 5th power. However, in algebra, start getting used to, because in algebra, we usually do not like to leave the answers with negative exponents. So what do? We're gonna have to apply the negative exponent rule. Remember the negative exponent rule? Every time you have a base with a negative exponent, you're gonna flip the base. Okay, remember this b is like it's over 1. And basically what you're doing, every time the exponent is negative, you're gonna flip it. So when the base is negative, you flip the top goes to the bottom and the bottom goes to the top. That's why the negative exponent rule looks like this, what I wrote over here. Okay, so what I'm going to do is I'm going to rewrite this. I'm going to write it like this: negative 2/3. I'm going to extend the bar. And x to the negative 7 in reality is right next to the negative 2 and the y also. Now, because it has negative exponent, it means that the x is going to go on the bottom, okay? And the y, because it also had a negative exponent, also goes on the bottom. So my answer is going to look like this. Negative 2 stays on the top because it doesn't have a negative exponent. But the x will go to the bottom next to the 3, but now with the exponent positive. And the same thing is going to happen with the y. It goes to the bottom next to the 3. Okay? And that will be the final answer. However, I think in the homework, you can leave your answer like I have it here in colors. All right? Let's go to the last problem. All right, the last problem, problem number 5. I'm going to do a similar one. Okay? Let's say you have 35 over 50, and then on the top I have x to the 36th power, and on the bottom I have x to the 40th power. Okay, Again, I'm dividing two monomials. The top is a monomial, the bottom is a monomial. How do we divide that? We're going to divide the numbers with the numbers. Let's divide them. Use the calculator. Okay, so I'm going to do 35 divided by 50. And you can see I got a decimal. Now, even though you can write the decimal, in algebra, we prefer working with fractions. So I'm gonna click on the circle, and you can see I got 7 over 10. So here, 35 over 50 is 7 over 10. Now I'm gonna divide the letters, the x's. I'm gonna keep the x, and what I'm gonna do with the two exponents, I'm gonna subtract them. Again, use the calculator if you don't remember how to subtract these numbers. Okay, so 36 subtract 40. And you can see I got -4. Okay, now usually in this assignment, this will be the final answer. However, in algebra, we prefer not leaving answers with negative exponents. So I'm going to rewrite it. How do I rewrite it? How do I simplify? I'm going to apply the negative exponent rule that basically said every time you have a negative exponent, you're going to flip the base and the exponent turns on positive. So if I rewrite my answer here, it's going to look like this: 7x to the -4 power over 10. And if you notice, the x has a negative exponent. And when you have a negative exponent, that x is on the top of the fraction. So you really want it on the bottom of the fraction because that's what the negative exponent is saying. That's why my final answer is going to be 7 over 10. Then now the x is on the bottom next to the 10, but with a positive exponent. Okay? I hope this helps.